Okay, so we missed a little bit of lesson 70. We didn't quite finish it, so I'm going to finish it now. This problem says a single die is rolled 3 times. The results are 1, 4, and 3 in that order. What is the probability that the next roll will produce a number greater than 2? Well, first of all, those first 3 rolls don't have anything to do with the probability of whether you can, when the probability of rolling something greater than 2. The first 3 rolls don't affect the 4th roll at all, so you can just ignore those first 3 rolls. Just like when you flip a coin, whatever you get the first time does not affect what you'll get the second time. It's the same probability it ever was. So really, this problem is just finding the probability of rolling a number greater than 2 when you roll 1 die. All right, so here are the possible values you can get when you roll a die. There are 6 possible values you can get. So when we're talking about the probability of rolling a number greater than 2, we know that it's going to be over 6 because there are 6 possible outcomes. And that's what goes in the denominator of a probability, all the possible outcomes. So there are 6 possible outcomes. The numbers greater than 2 that you could roll would be 3, 4, 5, and 6. So there are 4 rolls you could get that would be greater than 2. So that is the number that goes in the numerator of the fraction. That's the number of events that fulfill being greater than 2. So 4 over 6 is the probability of rolling a number greater than 2, and you can reduce that to 2/3. All right. The next problem is talking about what happens when you roll 2 dice. So we have to look at all the values you can get when you roll 2 dice. And this box shows us all the possibilities and how they could happen. All right, when you roll a 1 and a 1, that's 2. When you roll a 1 and a 2, that's 3. When you roll a 5 and a 6, that's 11. So all different kinds of ways. This is showing every possible outcome when you roll 2 dice. So 2 dice are rolled. What is the probability that the sum of the numbers rolled is a 7? All right, so you can see from this chart that there are 36 possible outcomes when you roll 2 dice. All the ones that are 7, there are 1, 2, 3, 4, 5, 6 of those. So the diagonal right here, that's how many ways you can get a 7. You can have a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, and the dice look the same, but they are in fact 2 different dice, so you have to count that twice, and a 5 and a 2, and a 6 and a 1. So that's how many ways you can get a 7 out of the total 36 possibilities you can get. So the probability of getting a 7 is 6 over 36, or 1/6. The probability of getting a number greater than an 8, look at all the numbers that are greater than 8 in this chart, right there. So there are 10 of them, 10 numbers that are great, 10 rolls you could get with your 2 dice that are greater, their sum would be greater than 8. All right, so probability of getting a number greater than 8 is going to be 10 over 36. So 10 possibilities over the total possibilities, 36. And if you reduce that, you get 5/18. All right, now we're going to look at talking about how you deal with it if you want to know something like the probability of getting a certain number of outcomes in a certain order. All right, so this is a little bit different. The probability of independent events happening in a designated order is the product of the probabilities of the individual outcomes. And that sounds very convoluted and hard to understand. But what it's saying is that if I want to look at some independent events, okay, like flipping a coin where each flip does not affect any of the other flips, okay, if I flip a coin 10 times, each time I flip it, that's an independent event because those events do not affect each other at all. It's always 1/2, always 1/2. The probability is always 1/2 that I'll get heads whenever I flip a coin. So it doesn't matter how many times I do it, or it's always the same. None of those events, none of those flips affect any of the other flips. All right, and what it's saying is that when you have some events like that that are independent of each other, they don't affect each other, and you want to know the probability of a certain list of outcomes happening, one after the other in a certain order, what you can do is just find out the probability of each event and then multiply them together. So, for example, suppose I flip a coin twice, and I want to know the probability of getting heads first and tails second. So I want to find out the probability of getting heads on the first flip and tails on the second flip. So in order, two independent events, what's the probability of that happening? All right, so the probability of getting a head first and then a tail is just the product of the two probabilities. The probability of getting a head, like we said before, is 1/2. The probability of getting a tail is 1/2. So the probability of getting a head and then a tail is the product of those two things. 1/2 times 1/2 is 1/4. And that may not seem obvious of why that is, and I'm going to show you a picture that helps you understand why it is that the probability of flipping heads and then tails with two flips of a coin is 1/4. All right, so you can see why this is true. You're gonna toss the coin twice. So on the first toss, there are two possibilities, either heads or tails. One of those two things is going to happen. On the second toss, if it was heads first, there are two possibilities for that second toss. It can still be heads or tails on the second toss. Same thing if I flip tails first. Second toss could be heads or tails. So we're going to look at all the possibilities when you flip a coin twice. What's the possible sequence of events? All right. So one way it could happen would be that you would flip it. So we're looking for the probability of heads first and then tails. So the first thing that could happen is you could flip the coin, and the first time it would be heads, and the second time it would be heads. So that's one possibility. You get heads, and that's not what we're looking for. All right. Another possibility is that you can flip the coin and you would get heads first and then tails. So that's another path, another thing that could happen when you flip a coin twice. You can get head first and tails second. So that's the second possible thing that could happen. Then another possibility would be that when you flip the coin, the first time you get tails and the second time you get heads. So that's another possible thing that could happen. Tails, heads. So that's three possibilities so far. And then the last thing that could possibly happen would be you'd get tails first and tails second. So you can see that there are four pathways on this coin tossing event, and four possible things that could happen if you flip a coin twice. You could get heads, you could get heads tails, you could get tails heads, and you could get tails tails. Four possible events, four possible ways this could play out. And only one of them is the one we want, which is heads, tails. We want to get heads first and then tails. So we're looking at this situation here where you flip the coin, you get heads first and then tails. That's what we want. There's one possible way that can happen, and there are four total ways of doing this. So the answer for the probability of heads first and then tails is 1/4. There's one way it can happen. There are four possible things that could happen. So the answer would be 1/4, just like we saw in the previous slide where we said all you have to do is multiply the probability of getting a head times the probability of getting a tail, and that's 1/2 times 1/2, which is 1/4. So this picture is just to show you why what happened in the slide before this is true. You can multiply the individual probabilities of the events and then multiply them together to get the answer. All right, so let's look at a couple of other situations. You've got a fair coin and you're tossing it 4 times. You want to know what is the probability that the first 2 outcomes will be heads and the last 2 outcomes will be tails. So we're looking for the probability of heads, heads, tails, tails. We're flipping a coin 4 times. We're looking for the probability that our outcome would be heads first, heads again, tails again, and then tails again. So we're looking for that order to happen when we flip this coin 4 times. How many possibilities are there when you flip a coin 4 times? Well, it turns out there are 16 possibilities, and only one of them is heads, heads, tails, tails. And so you don't have to draw out this whole big tree like we did on the other one. All you have to do is remember that the probability of a certain order of independent events happening is just the individual probabilities multiplied together. So probability of getting a head when you flip a coin is 1/2. The probability of getting a head when you flip a coin, again, is 1/2. The probability of getting a tail when you flip a coin is still 1/2. The probability of getting a tail when you flip a coin is still 1/2. You multiply all those together and you get 1/16. All right, now you've got the spinner shown is spun twice. What is the probability that the spinner stops on the 4 first and then on the 3? So you're spinning it twice, and you want to know the probability of getting a 4 first and then a 3 on your second spin. All right, same thing. Probability of getting a 4 first and then a 3. Well, you can just look at each of the individual probabilities. The probability of getting a 4 is 1 out of 4, 1/4. There's 1 4 on the spinner, and there are 4 equal size areas there, 4 numbers you can get. So the probability of getting a 4 is 1/4. The probability of getting a 3 is also 1/4. So you take the individual probabilities for getting a 4 and getting a 3, and you multiply those together, and it gives you 1/16. So the probability of getting a 4 on your first spin and a 3 on your second spin, in that order, is 1/16.